Hello and welcome to this section of the Calculus Derivative Tutor. In this section we're going to continue working with derivatives of trig functions, working some extra problems. A little more complexity, not crazy though, because once you understand the basics of the trigonometric functions, what their derivatives are, and if you have a good solid foundation in the quotient rule and the product rule, which was the purpose of the last couple of sections, then you're not going to have a problem with this, but you do need to get practice, so that's what we're going to do. Let's go and say we have the following function. F of x is equal to x times the sine of x times the cosine of x. And we want to take its derivative. Now at first glance, if you saw this on a test and you never really tried a problem like this, you might say, whoa, challenge problem. Because you know how to take the derivative of sine, you know how to take the derivative of cosine, you know how to take the derivative of this, but they're all multiplied together. And furthermore, when we talked about the product rule, function A times function B, you know how to do that, but here there's three functions. So first you're thinking, this is outside the realm of anything I've been able to do. But here's a piece of advice I want to give you. Anytime in math, doesn't matter if it's calculus or anything, chemistry, physics, whatever, okay? If you know that what you're doing is legal, then do it because you know that it's legal. You need to know those rules like you know the traffic laws, right? You know not to run red lights. You need to know the rules of math. And if you know those, then even if you're not quite sure how, a professor might do this problem, if you were doing something legal, it's okay. So let me show you something that you might not have guessed right away. If you rewrite this guy as follows, I think you might understand how to do it. X times the sine of x times the cosine of x. Exactly the same thing, right? But here, when I put parentheses, I'm kind of implying to you that this is sort of one function. This is sort of function number two. So this is function multiplied by function. Yes, now this guy is comprised of two things multiplied together. We'll deal with that later. But at a big picture, it's this guy multiplied by this guy. So we can apply the product rule to it as if it was written that way. As an aside, I could have written the parentheses around these guys. I could say x times this guy, and this would be function A, and this thing would be function B. You would get the same answer. You know that doing this parenthesis grouping is legal because you know that multiplication doesn't matter the order in which you do the multiplication. So let's see what we get. So let's go and take this derivative using this. The derivative will be the first function, which is x times the sine of x times the derivative of the second function, cosine of x prime, right? Plus the second function, cosine of x times the derivative of the first function, x times the sine of x, like this. So the first function times the derivative of the second plus the second function times the derivative of the first function. Now, even if you don't do anything else on your test, your professor will give you some credit even for writing that down, even if you don't know what to do next. But let's just take it one step at a time. Here we'll have x times the sine of x. What is the derivative of cosine? Now I've intentionally erased all of the trig guys that the trig derivatives, because you really do need to memorize them. But if you're having trouble, just remember that the derivative of cosine is negative sine. So let's write negative sine of x. That's this derivative. Okay, plus. And over here, we're going to write cosine of x. And right now, instead of taking the derivative, I'm going to rewrite it as the sine of x derivative. So really all I've done in this step is I've taken this derivative, but I've rewritten everything else. Nothing else has really been done. The reason I'm doing it this way is because I want to point out to you that this derivative is itself a product rule. It's this function times this function. So if you were going to take this guy, it would be first times the derivative of the second plus the second times the derivative of the first. So it would be x times the derivative of this plus the second function times the derivative of the first function. So this guy would be x. What is the derivative of sine? We learned that just a minute ago. It's cosine of x, right? Plus sine of x. What is the derivative of x? It's just 1. So ultimately, this is going to come down to x times cosine of x plus sine of x. So you see, we've rewritten it, we've gotten it down to this point. We recognize that to take this derivative, I need to use the product rule again. So I go off to the side of my paper and I do that and I get this. So now when I go back and reintegrate that into my problem, f prime of x is equal to, let me take off the parentheses now because there's really no need for them anymore. So up here we'll have this negative is going to come out negative x, sine times sine is sine squared x. So I'm just rewriting this term here. Next I'll have plus cosine of x. And just to keep it straight, we'll open a parentheses and write this in, which was x times cosine x plus sine x. And so the only thing really left to do is rewrite these terms. F prime of x is equal to negative x times the sine squared of x plus x times the cosine squared of x, because cosine times cosine, plus cosine times sine. Let's just make sure it's correct. So we have x times the sine, negative x times sine squared of x, plus x times cosine squared of x, plus cosine x times sine x, and that is the full answer. So you see, we've gone, and notice how short this problem is. I mean, I can give you an equation in Algebra 1 to solve that's more complicated than this, really. It just looks ugly because you've got these three guys. So I did the grouping like this and the grouping like this and then did the product rule on it. Once I got down to taking this derivative, now I take that derivative. Now, here you see the real beauty and power of showing all of your work. When I got to this point, if I tried to take this derivative at this time that I wrote this line down, then I'm definitely going to make a mistake because I'm going to start trying to take the derivative of this product somehow in my head without showing it. But you know, that's the beauty of it. You get a double whammy out of it. Number one, you show your work, so you're going to get more credit. Number two, when you blow it out like this, you say, oh, well, I know how to take this derivative. I did that in like a problem previous. So I'll just do product rule again, get this answer, reintegrate it back. And by the way, on my paper, I would do it exactly as I've done it on the board. You know, a lot of people email me and they ask me, you know, are you solving these problems, you know, like this all the time, or is this just something you're doing to teach us? Actually, most of the time, almost all the time, this is exactly how I show it on my paper. I mean, virtually identically. If I got down, I would literally write the curly braces, I would literally draw a little arrow, and I would literally take this derivative, however many lines it took, and then I would literally reintegrate the answer, showing everything in there, because that is going to be the quickest and easiest way to convey that I know what I'm doing to my professor. And even if you get the wrong answer somewhere along the way, you're going to get more credit and more points that way. Okay. So our next problem is f of x is equal to the sine of x over 1 plus cosine of x. All right, 1 plus cosine of x. All right, so how do we do this? We want to take this derivative. The first thing you need to notice, big picture, is that it's a quotient. It's a function on top divided by a function on the bottom. So I'm going to try to apply the chain rule. I'm sorry, not the chain rule, the quotient rule, exactly as we've been doing before. So it would be bottom 1 plus cosine of x times the derivative of the top, sine of x derivative, minus the top, which is the sine of x, times the derivative of the bottom, 1 plus cosine of x, derivative marked there, over bottom squared. So it would be 1 plus cosine of x squared. Make sure you understand, bottom times derivative of the top minus the top times the derivative of the bottom squared. Okay, so let's go and take these derivatives. F prime of x. So what we'll have is 1 plus cosine of x. What is the derivative of the sine function? That's the one that you should always remember because it's just cosine. Cosine of x minus the sine from here, sine of x. What is the derivative of all this? Well, the derivative of this is 0. What is the derivative of cosine? It's negative sine of x. All over 1 plus cosine of x squared. All right, so now we have some pretty straightforward work to do. Let's distribute the cosine in. So this times this is going to give me cosine of x. This times this is going to give me cosine squared of x. Let's keep the negative on the outside for now, and let's work on this guy. We'll have negative sine squared, negative sine squared x. And in the bottom, we'll just have the 1 plus cosine x squared. And I think we're about ready to write almost the final answer down. F prime of x is equal to. What we're going to have here is cosine of x plus cosine squared of x. Now let's take care of these double negatives, plus sine squared x all over 1 plus cosine x squared. Now you may look at this and say, haha, I'm done. There's nothing else I can factor out, whatever. But remember, I told you in the last section, if there's one trig identity you need to remember, and that's always going to be that cosine squared plus sine squared of the same number or variable is always going to be 1. Always. So what you really have on the top, when you look at it, is cosine x plus 1. That's what we have on the top because this is 1, right? So let me wrap it in parentheses to help you out here. On the bottom, you're going to have 1 plus cosine x squared. This entire numerator can cancel with one of the guys in the bottom. So the real answer for this derivative is equal to 1 over the bottom, 1 plus cosine x. 1 plus cosine x. And that is the answer, 1 over 1 plus cosine x. So, you know, if I were a professor and you got down to this part, I'd give you most credit because you knew what you were doing, you took the derivatives properly, you just didn't notice that. But this is an awful big simplification. It's, to me, when you get into the realm of calculus and trig, if you don't notice that cosine squared plus sine squared is 1, it's almost the same as not knowing when two things cancel on a fraction. Like if you have x squared on the top and x cubed on the bottom, you know that you can cancel some x's, right? Or if you have negative 2t plus 2t, you know that those two t's, they cancel out, right? Because it's pretty obvious. So it's correct, but I think anybody would kind of tick off a little bit if you didn't simplify that. But you're in the big leagues now. You're in calculus, you're doing stuff, you're flexing your muscles with trig and algebra. So if you don't notice that this is equal to 1, then it's a pretty big deal. There are lots of trig identities though, so believe me, they're not going to expect you to know all of them. It's just that this is kind of one of the most fundamental that there is. So try to commit that to memory and it will come up over and over again. So what we're going to do now is erase the board and work another problem. And this one's going to end up taking maybe even both boards because it's going to be longer, but you'll find that it's really no harder. It's just that once you get down into the nuts and bolts of it, simplifying it takes a little bit of time. Okay, so our next problem is y is equal to tangent of x minus 1 over secant of x. So there's a nice friendly looking function. Tangents and secants usually frighten people and kind of makes sense a little bit. But ultimately you have a numerator and a denominator, so you're going to be able to use the quotient rule on this when we take the derivative. So we take the derivative as follows. Bottom secant of x times the derivative of the top, which is this guy. Tangent x minus 1, take its derivative, minus the top. Tangent of x minus 1 times the derivative of the bottom, which is the derivative of the secant function. All divided by the bottom squared, which is secant squared. So I'm going to write it as secant squared of x. But everything else follows. Let's take these derivatives and see if we can simplify. Y prime is equal to secant of x times. What is the derivative of tangent? Because we're taking the derivative of this guy. What is the derivative of tangent? It's secant squared of x. The derivative of 1 is 0, so we just close it off. Next, we'll have tangent of x minus 1. What is the derivative of secant? It's just tangent of x times secant of x. So you see what I'm saying? You really do need to memorize them, because if you have to look this up in a book every time or derive it, it's just going to take too long. And then underneath, we're going to have secant squared x. Okay, secant squared x. So let's go ahead and simplify. Y prime. Secant times secant squared is secant cubed x. Over here, we have something kind of complicated. We have tangent minus 1, and we have this big guy right here. So let's take it one step at a time. Let's leave the minus sign outside for right now. This is kind of like one term. You can see it's multiplied together. This has got the minus sign. So let's take it and multiply it times this, and then after that we'll multiply it times this. So what we'll have is tangent squared times secant. Let me write the x's in here to make sure you know. Tangent squared x times secant x. That's this multiplied by this. Minus this multiplied by this is just going to be tangent secant. Okay, so that's everything on the top. And on the bottom is secant squared x. So let's take care of the minus sign here. Y prime secant cubed of x minus tangent squared x secant x. Minus times minus is plus tangent x secant x. All right? And then we do a division sign. On the bottom we have secant squared x. Now you might get to the end of your rope here and say, we are done. I can't do anything more than this. But what you see right away if you look carefully, because you can't combine any of these terms, but what I do see is that I have a secant cubed, I have a secant, and I have a secant, and I have a secant squared. So, you know, I can cancel them. Now, basically what you're doing is you're factoring out a secant from the top and from the bottom, and then you're canceling on the left-hand side. But I think you're big boys and girls enough to know that you can really just strike this out along with this, along with one of these secants here. So I'll put a 2, and I'll strike this exponent out, telling me that I have 1 left in the bottom. So don't forget what you're really doing. You're factoring out a single secant, just one secant from the top. You're factoring out a single secant from the bottom, so you have secant over secant out front. You cancel them out. That's exactly the same thing as just striking through your paper. I have a secant here, leaving me with 2 of them. This entire secant cancels, this one cancels, this one cancels, one of them leaving me with just the one that's left over. So when I continue, I will have secant squared x minus tangent squared x, this is gone now, plus tangent of x over secant of x. Okay, so really this is the answer, essentially. I mean, you could circle this on a test. I think you would get credit for it. But let me simplify it a little bit. It's a little bit subjective when you get into advanced math, how far you should simplify something. But I'm just going to show you, mostly because we're learning how to use these guys, how to use these identities. I'm going to teach you how to simplify it a little bit, mostly for education purposes. Tangent x. I honestly think that if you would leave the answer in that form, that's fine. But this is exactly what we had from the last step, so there's really nothing new here. But when you look at a bunch of tangents, you can almost always rewrite it as sine over cosine and get something simpler. Also, notice that on the bottom I have a secant. So remember, it's the rainbow: sine, cosine, tangent, cotangent, secant, cosecant. So this secant on the bottom, if I were to rewrite it, it would be in terms of a cosine, 1 over cosine. I know that this is going to be in terms of 1 over cosine. I know that these tangents are going to be basically sines over cosines. So because I see a cosine on the bottom and all these cosines on the top, I know that I'll be able to cancel them. So like I said, it's a little bit subjective, but you're certainly not going to get penalized for it. So let's just do it and see where it takes us. On the top, secant squared can be written as 1 over cosine squared. 1 over cosine squared x. That's this first term, minus. Tangent squared. Tangent is sine over cosine. So it's sine squared of x over cosine squared of x, because the whole thing's squared. This guy's tangent, which is just sine of x over cosine of x. So that's the numerator. The denominator is secant, which is 1 over cosine. 1 over cosine of x. Okay, so here in the denominator of these fractions, I have a cosine everywhere. I also have a cosine here. So again, what you're really doing is factoring out the 1 over cosine and canceling them, but it's the same exact thing as canceling this with one of these, with one of these, with one of these. So you cancel this completely, but you still have 1 left over in these terms. So y prime, in this case, would be 1 over cosine, minus, this would be sine squared over cosine, and this guy would be sine. And the bottom is just gone now because it's 1. So you might think, well, we're getting a little bit simpler. Okay, we're getting a little bit simpler. So now we can look a little bit further. 1 over cosine. 1 over cosine, I can change it back into a secant. So I can change this back into a secant of x, right? Let me do the last term here. Sine of x is just going to be left alone. Now we're left with this middle term here, sine squared over cosine. Sine squared over cosine. How can I handle that? Well, when you think about it, sine, let me do a little side here. Sine squared over cosine can be written as sine times sine over cosine, which is sine times tangent. Sine over cosine is always tangent. So sine, so here we're going to have secant of x. And here we're going to have sine of x times tangent of x. And that's the answer. So what we're going to have is secant of x minus sine of x times tangent of x plus sine of x. So that's what we have. Now, this is, I think, maybe a little more simplified than this. But this is really, a fine answer to have. And it's totally okay to probably leave it that way. The only reason it's not perfectly, perfect, so to speak, is because you got a big fraction there. And when you do this work, basically you eliminate that fraction. Is this truly more simplified? I mean, not really. I mean, it's a little more, but who cares? I mean, you take the derivative correctly. That's all that matters. If you plot this function, and if you plot this function, or heck, even if you plot one of these earlier versions, you're going to get the same exact looking plot. All of the rest of it comes down to subjective details of how far do you want to take it. But ultimately, you're doing the same thing. Bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Take the derivatives using the trig derivatives that we've learned. Doing the multiplication, the simplification, we get down to an answer that we think is pretty simplified. The only reason we take it farther is because we realize that secant is 1 over cosine. Tangent is sine over cosine. So when I notice that I have all these cosines everywhere, I know I'm going to be able to cancel them. So we go ahead and do it, and we figure out that we get rid of our denominator altogether. So even though you kind of have to go through getting it into sine and cosine to cancel it, and then go back into secant here, looks a little bit like a long way around to get to the answer. But in fact, the answer that we get is, I think, a tad more simplified. So, you'll probably get full credit for something like that. Whereas here, I'd probably get full credit also, but some professors may not. They may want you to prove and show that you really are comfortable with the trigonometric functions. So we're done with this section, and what we've done in this section and also in the last is we've introduced the 6 trig functions: sine, cosine, tangent, cotangent, secant, cosecant. And we provided their derivatives. We've actually shown how you can prove a lot of those derivatives are true just knowing the quotient rule, the product rule, the trig rainbow that I'm reintroducing to you if you don't already know, and also the basic derivatives of sine and cosine. So if you truly forget the derivative of cosecant, you can derive it. However, on a test, not a smart idea. You need to memorize them. So sit down on a nice park bench somewhere and just say them over and over about 6 or 8 times or 10 times or however long, and you will eventually memorize them. When you do your problems, make yourself recall the derivative from memory and then check yourself. Don't always flip to the table and then do your work, because then you won't know if you really remember it or not. Make yourself pull it out of your head, and then if you're getting it right, pat yourself on the back. If you're getting it wrong, then go back and memorize them a little bit better. That way on your test, when you're trying to take the derivative of a cosecant or something, you're not going to struggle with that. You're going to know that, and then you can go and just work with the algebra, which is really, you can see from these problems, 90% of everything you're doing. So this is using trig derivatives, but you're also going to be using quotient rule, product rule, and here in the next couple sections we're going to introduce the chain rule, which is going to be something even more important and used in calculus all throughout as well. So gear up for that. I promise you it's not going to be any harder than anything we've been doing. Most of calculus just boils down to rolling up your sleeves, understanding what we're doing here, and doing the basic algebra and simplifying the results.